Hi everyone, Frankie from easypowerwall.com. For the moment I'm under my solar array. My favorite hideout place if my better half comes up with a new honey-do list. But that's of course not the only reason why I'm here. Today I want to talk about this box here under the solar array. It's the solar combiner box. Wow, that's a great surprise to start 2024. It's a new milestone. Let's add another 9,000 this year. Of course, I still want to talk about the solar combiner box. I need a new one to add 9 other panels on the roof of the shed, and I will build one together with you. It's easy and a rewarding task. I will do it step by step. The first question we have to ask ourselves: why do we need a PV or solar combiner box? In grid tie systems, we find strings of 10 or 12 panels in series directly connected to the inverter. In off-grid solar arrays, we often use low voltage charge controllers. So most of the time we have 3 panels in series. To combine this series of 3S solar connections, we use a PV combiner box. Most of the combiner boxes have PV fuses and DC breakers. My build differentiates because I use anti-flowback or shottky diodes. This is an extra security layer. More info about that later. What do we need to build the combiner box? We need the fuse holders, of course, with the fuses. We need MC4 connectors, a lot more than these, but a lot of MC4 connectors. A power distribution block, a DC breaker, an SPD, a surge protection device, and I'll add always anti-flowback diodes. I will come back on these later, but this is the difference between a DIY solution and a commercial off-the-shelf solution. When you buy a box, it's probably equipped with a metal sheet and a DIN rail. This is a used box. Of course, I will provide a link where you can buy a new one with the same size. But if you buy one, make sure you have 2 layers with DIN rails. That's very important. I had this layer of compressed plastic available, so I will install this one. I have to drill a few holes, but I will come back later when it's done, and then we can start building the combiner box. Let me go quickly over the whole setup. Power will enter the box via a MC4 connector. You have to drill the holes here at the bottom of the box. I will install the DIN rail at this location. I won't fix them or clip them into the DIN rail, but this is how it will be installed. After the fuse holder, we make a connection to this anti-flowback diode. So the 4 wires from the anti-flowback diode will go into one power block, and the combined positive string, I have 3 of them, but I will use only 2. One goes to the positive side of the DC breaker, and another positive will go to the SPD or surge protection device. Here we have the SPD or surge protection device and the DC breaker. That's an old model. Of course it will be replaced by a new one. I ordered one from the same brand, EARU. It's a brand I really like, good quality. I need some room here at this side. Also on this side I will drill 4 holes for the MC4 connector, and the negative wires will go here on the side, go to the power block divider, and then go to the surge protection device, and one will go to the DC breaker. This won't go anywhere, that's for sure. Then we can start making the larger holes for the MC4 connector. I've set the markers where I will put the MC4 connectors. Here I have a square for the 4 positive connectors. These are the negative ones. So if you're not sure if they will align properly, or if you have enough room between the connectors, make sure you try before you drill the holes. But this seems to work fine. You need to drill 16mm holes. I made the holes for the MC4 connectors. Next step is 3 additional holes for DC and ground. I'm gonna use this item. And this one too. I will attach the anti-flowback diodes with M4 screw, so I will drill with 3mm and then tap the M4 thread. Use this tool to make some M4 thread so we can attach the anti-flowback diode to the heatsink. I used this skill before to make the bus bars. As you can see, it was a bit of a challenge because on the heatsink you have these cooling elements, but at the end I managed to but as you can see, I made an error. I was drilling on the tip of the cooling element and I had a hard time to make a decent hole. I most probably won't win the points of the jury for this one, so but just learn from my mistakes. To mount the heatsink on the base plate, I use this little pencil with a long tip. Hope it's just long enough. Yes, here it is. Layout is ready. Now we can start with the cabling. I will start with the cabling between the anti-flowback diodes and the fuse holders. I have to attach the diodes. I will come back to that later, but I will first start with building the cables. What do I need for this step? I need, of course, wires, pliers, and I'm going to use the tool. Maybe some of you notice this is a crimping tool. I will need this also for the MC4 connectors. But this works also very well with these copper lugs. For the connections I'm using 2.5 square millimeter and I remove about 1 centimeter from the end. Now these lugs are, the width is a bit too much for the connector. I have to close this a little bit so it fits in the MC4 plier. So it looks like this. Hope it's visible on the camera. As you can see, it fits now. Enter the wire and you crimp it. As you can see, very solid connection. No way you can remove this. You can add a little solder too, but I don't think it's necessary. I'm not gonna do it. I did this at the previous build, but it's not necessary. So this is how you make a very strong and solid connection. So we have 4 cables towards the fuse holders. Now I'm gonna make 4 more from the anti-flowback diodes towards the power block divider. So while you were enjoying the movie, I created all 8 or the 2 cable sets. Before installing them, I will first attach the anti-flowback diodes properly. For the techies, I will give some information about the anti-flowback diodes, how they work. Before attaching them to the heatsink, make sure it's dust and grease free. Next step is add a little thermal grease. Maybe you have some left over from an old computer build or so. Add a little bit, not too much. And then use a piece of plastic to make sure you put a nice layer, very thin layer, just like this. And now we're gonna install the anti-flowback diode on the heatsink. Very important, there are 2 connections, one with the open end, one with the closed. The one with the open end must face towards the fuse holders. As simple as that. Of course, I'm gonna have to do the same on the other side as well. But this is how it works. Make sure to put enough tension on the screws so they're well attached to the heatsink. I will start with the top first. I'm going to connect the wires between the anti-flowback diode and the fuse holder. Next step is to determine the correct length, add a ferrule, crimp it, and connect it to the power block divider. Of course, distance is not critical. They won't be all the same length, but there's only a few centimeters difference, so don't worry too much about that. This is a great crimping tool. Can really recommend this one. Now you open the, and here you can open and close the screws. I really like these power block dividers and I really recommend them, but it's a pity they use two different hex screws for one single device. This should be done on another way. One single size hex key, but it is what it is. I'm cutting the wire to the end of the screw, and then it's close to a perfect fit. I always like to have some wiggle room. Perfect. I have put the board back in its casing just to check the wiring. As you can see, the wiring between the positive side and the fuse holder is very short. So I will prepare these MC4 connectors, so I only need like 6 centimeters of wire. On the other side, the negative side of the solar combiner box, I need wires from here to here. Just like this. This should be enough. So that's the length I need. And I'll cut 4 of these wires. So I have pre-cut the wires for the positive side, pre-cut the wires for the negative side. Let's make some MC4 connections. I will give a small training how to make a proper MC4 connection. If you know how to do that, you can skip to the next level. We have the 2 connectors. We have a male connector and a female MC4 connector. Of Of course, they fit perfectly together. I won't clip it right now because then it's a bit difficult to undo the connection. But if you order a package of 20 connectors, you get a tool to undo the connection. With the connector comes a bus. It's to connect, to make the electrical connection. It might sound weird, but in the male connector, we install the female bus, and in the female connector, we install the male bus. This is something you have to keep in mind, so you don't make any mistake. This is how the MC4 connector works. What else do we need to complete this step? I have a few wires. I need a wire stripper and MC4 pliers. Let's build our first connection. I have to remove 12 millimeter. So this is right. Then we put our bus into the MC4 pliers. Put your cable into the bus. Press it till the end. Release. And your connection is made. As you can see, it's a very strong, well-made connection. Impossible to remove it, so this will last a long time, if not forever. To complete this step, enter it in the connector and you will hear a little click. Click. Now it's attached. And now we can mount it into our cabinet. I already made one, this is the second one, and we need to make a few more. For the male one, I need a longer cable. I mentioned this before. For the male MC4 connector, I use the female bus. Mount it like that in the MC4 plier. Release. It's a very well made connection. As with the female connector, just slide it in the connector. You hear the little click and you know your connection is made. As you can see, this goes very smoothly and very quickly. I'll make the other cables offline, and when I'm done, I'm coming back to install them in the Combinerbox. With the basic cabling done, we're almost getting there. Now I will make a connection between the power block and the DC breaker and the surge protection device. I'm going to use the regular solder cable for this. I have some 6mm cable left. You know, it's a 4-string system, so the combined current, maximum current, can be 40 amps, so 6 square millimeter will do the job. I want a clean straight cut, so I'm using this tool. To one hand, very easy job. I really recommend this one if you work with solder cables or other larger cables. Works very well. I also prepared the cables for the negative side. These crimpers are made for 6mm, but you have to squeeze a lot harder. Well, main cabling is done. Of course, we need to install the MC4 connectors, but I will first install the box against the wall, because with the connectors in place it will be very difficult to reach the holes to tension the screws. So I will remove the hardware, install it against the wall, and then install the MC4 connectors. Choose your location wisely. As you can see, it's protected from rain. The second one is protected from the elements by the solar panels and protected by my two guards. Ready to load the gun with the fuses. I'm using 16 amp fuses. Some PV combiner boxes use protection on the positive and the negative side. For me that's a bit overkill, so I'm using it only one side, and I prefer to invest the saved money into the anti-flowback diodes. That's more useful. I installed the board in the cabinet, and one of the final steps is installing the MC4 connectors. I've already done one, so I will populate the others. I won't bother you too much with this process, but of course when it's done I will show you the result. Here I have 2 rows of MC4 connectors. It's important to put the right tension on the MC4 before you start the second row. This is the tool I talked about. If you order 10 or 20 pieces, you already get an MC4 spanner. It's included with the order. Distance between the MC4 and the fuse is limited, but don't try to make the connection as short as possible. I will make a pigtail like this, so I don't want to put any stress on the cables or on the connector. All connectors are installed. The only thing I have to do is connect the wires with the power block and here with the fuse holder. But first I'm gonna take a cup of soup. My hands are freezing. But if you like my work so far, please give me a thumbs up and consider subscribing to the channel. Well, that wasn't a lazy Sunday project, but it's finished now and I'm very happy with the result. As you can see, the negative wires are well in place. And maybe a tip, keep your spare fuses at the bottom of your PV combiner box. My older box is already 4 years in service. I never had to replace a fuse, but you never know. Overall, I'm very happy with the result. I hope you like the result too. But if you have comments, if you see things that I can improve, use the comments below. The solar combiner box.